So I think we stopped at 7. So explain whether the following equations are proportional. So there are two different questions, okay? And you can explain it in very different ways. So let's take the easy approach here, and I'll actually talk about the other approaches. So one approach you can say is that this one, if I were to write like that, we don't write the plus 0 because it's not necessary, but it tells me that my b, remember, y equals mx plus b. This is my y-intercept, so that particular equation has a positive slope, so it's going to go up, and it has a y-intercept at 0, so it starts 0 and it goes that way, right? Now, so therefore, this one is a proportional equation because, what do you call it, goes through 0, 0, so that could be your simple explanation. Well, this one it does not, because let me just change it. And then the simple explanation would be that this has a slope of 3, so that line is going to go across 3, and it's going to go up like that. I don't know, well, the steepness of it, I don't know, but I know it's positive, and it crosses the y-intercept at plus 3, so definitely doesn't start at 0, 0, and therefore this is not proportional. So that's one way of thinking about it. I'm going to take the other approaches. So you can create a table, and if you were to create a table, just to show you this y values and x values, so I'm just going to pick, like, let's pick 0, 1, and 0, 1, and 2. So when x equals 0, you would plug in 0, it'd be 3 over 2 times 0, and you get y is 0. When x equals 1, if x equals 1, it'd be 3 over 2 times 1, which would be, and I'm going to write 1.5 because that's probably easier to see. And then when x equals 2, it would be y would equals 3. So you can substitute, and you can see that the relationship here is 1.5. So your, what do you call, if I were to do a k equals y over x for these two, and then k equals y over x for these two, and see if their constant of proportionality is the same. So for here, I would get k equals y, which is 1.5 over 1, which is just 1.5. Right, so the constant proportionality of these two is 1.5. And over here, I would do the same thing, k equals 3 over 2. And we can change that to 1.5 as well. So you know that the constant proportionality is also the same. So therefore, this is a proportional equation. Well, this one, and again, I'm doing this the really long way. So y next, let's just figure out a few points. And again, pick 0, 1, 2, or 3. And when x equals 0, if I were to put a 0 over here, it would be 3 over 5 times 0 plus 3, I would get 3. When x equals 1, so when x equals 1, I would put over here, so it would be 3/5 times 1, and then plus 3, or just 3.6, which is the same thing as 3/5. And then when x equals 2, when x equals 2, it would be 6 over 5 plus 3, right? And that's 1 1/5 plus 3, which is going to give us 4.2. Now, if you do look for the constant of proportionality over here, okay, and you will see that again, k equals y over x, k equals y over x, k equals y over x. If I were to take the constant proportionality, it would be 3 over 0, which over 0, so k is 0. Over here would be 3.6 over 1, which is going to give me k equals 3.6. And then over here, you're going to get k equals 4.2 over 2, which we can simplify to 2.1. You notice that the constant proportionality is different. So another way of looking at it is how does the 0 becomes 3? It's times 0. How does the w times 0? How does the 1 become 3.6 times 3.6? How does the 2 become 4.2 is times 2.1? So you notice that this constant here is all different, whereas here it's all the same except for the 0, 0, of course. Okay. Moving on. 8. What is a constant of proportionality? So you have a graph, and again, maybe some of you like the table this way. So let's put the values here. The x is 20, 24, 26, 28, y is 30, 36, 39, 42, and we can assuming, I guess we can, I don't know if this is proportional or not. We can debate that. And so let's take this. Can I lower this? No. Let's take the first one. So I'm going to take this and write k equals y over x. And for this first one over here, I get 30 over 20. And k equals 3/2, or if you want, 1.5. Let's leave it at 3/2. 3 over 2. 36 over 24, so let's do that one. Equals k equals 36 to find the constant proportionality, which is the unit rate, right? 3 over 2. And we get 36 over 24, which if we divide top and bottom by 12, we got 3 over 2. So again, look, k equals the same. Next row, 39 over 26. K equals 39 over 26. And we can divide top and bottom by 13, and we get 3 over 2. And even the last one, k equals 42 over 28. We can divide top and bottom by 14. You get 3 over 2. So again, the unit rate, and then if you want to think about it, the unit rate would be 1.5 over 1. So if you were to extend this table and work your table all the way, so we got 20, 19, 18, and if you were to go all the way to 1, you would have this 1.5 over 1, right? So how does the 1 become 1.5? It's times 1.5. So everything here is times 1.5, times 1.5, times 1.5, times 1.5. And your unit rate, whatever this is talking about, is 1.5, whatever, dollars per hour, whatever this is. That's your relationship, okay? Number 9, if one equation is proportional, if an equation is proportional, right? So if you have an equation that's proportional, like y equals, it's always going to be in this format. Not going to have the plus 5 plus 2. It's not, this tells you that this particular equation goes through the origin 0, 0. If then the graph will always go through the origin. So whether is y equals 5x, y equals 2/3 of x, y equals 7x, or whatever it is, these will all, their y-intercept is 0, so they'll all go through 0, 0. And find the constant of proportionality. So again, I want you to pick a point. So with this one, if I pick one, well, let's both set in the classroom, right? So we got, and so I'm gonna draw a table for this. So we're talking about distance, and that's gonna be my y, and the time always is my x. That's my independent. So this is my I for independent, D for independent, and then I can. You don't have to do the table, but I'm just going to show you that 1, 2, 3, 4. For 1, I have 6, and it matches. For 2, obviously, I'm not going to have. So the only point that I can take, well, actually, I could have also taken 0.5. So let me just. So you're actually looking for a constant proportionality. So to do that, you take obviously points that are on the intersection. So you have 1 and 6, which I could have used. I also have this point, and this point is half of 1, which is 0.5, and that meets up nicely with 3. So in 0.5 minutes, he goes 3 feet. In 1 minute, he goes 6 feet. So therefore, way 8 is it's going through the origin. So this definitely, it's proportional. So for 2 would be 12. For 3 would be 18, etc. So if you want the constant proportionality, pick any of the points. So from the graph, you only had these 2 points that you could have definitely picked that were exact. So k equals y over x, or you could have used 6 over 1, doesn't matter. And you're going to find the unit rate. Well, you already know what the unit rate is. That the unit rate is that it goes 6 feet per minute, but you want the constant proportionality. So for the first one would be k equals y, which is 3, divided by 0.5, and k equals 6. Here, likewise, k equals y, which is 6 over 1, and the constant proportionality is 6. Okay, so you notice that this up and down relationship is times 6, times 6, times 6, times 6, and this is what we're looking for. Okay. 11. Which graph shows a proportional relationship? Well, one of the things we talked about today was that if they have a proportional relationship, it's going to be a straight line, and it's going to go through the origin. So this one, yes. This one, no. And this one, although straight line, it doesn't go through 0, 0. So the only one is that one in the corner. More 12. Find the unit rate. Okay, so find the unit rate. Again, you can do this. And this is hours, in hours. So you can find your rate. You can write your rate like this. And then if you divide top and bottom by 48. right? Divide this by 48 and divide this by 48, which is essentially what we're doing the other way. So let me just write 2,988 divided by 48 hours means that in each hour this person earned $62.25 per hour. Now, if you did this, right, K here is your constant proportionality. It's also your unit rate. So let's see what happens here. So Y, so now when you do this though, you got to figure out which one is your Y and which one is your X. This is your dependent and this is your independent. So you would have 2,988 equals K times X, which is 48. Divide both sides by 48, right? And isn't, I mean, if you look at this, it looks over here, it looks the same thing. So 2,098 divided by 48, isn't that what we did here? 2,098 divided by 48, and K equals 62.25. This is your constant proportionality, which is also your unit rate. So whether you do it like this or this, I think this is easier, right? It's up to you. 13, what is going on with 13? Local dam lets 75,200 gallons pass through it through a course of 8 hours. So here we have a relationship, and we can also already start writing that as a rate. So 75,200 gallons in 8 hours. We have that relationship on Wednesday. And on Thursday, it did 141,000 gallons over 15 hours. Find the constant proportionality that tells us how many gallons will pass through the dam per hour. Translate that, find a unit rate. So let's see if they're constant though, right? So, and if you find, does it say it's proportional? Well, let's do this one first. So Y equals Kx. Obviously this is the Y and this is the X. So Y is 75,200. Equals Kx, which is what we want to find, and X equals 8. Divide both sides by 8. And K, your constant of proportionality, is going to be, I have no idea, 75,200 divided by 8 equals 9,400. So K is 9,400, which we will then write it as 9,400 gallons per 1 hour. That's on Wednesday. On Thursday, well, let's see if it's proportional. So on Thursday, again, this is your Y, this is your X. You're going to get Y equals Kx, 141,000. Equals K times 15. Divide both sides by 15. And K, if they are proportional, Wednesday and Thursday, should be the same answer, divide by 15, and you get 9,400. And guess what? So the water always flows at the same speed of 9,400 gallons per 1 hour. So this is your constant proportionality, 9,400, and which you can then change it to your unit rate. Okay. 14, okay, so we have a few more. Which line has a constant proportionality between Y and X of 1? So we have to find which one has a constant proportionality. So let's stick to the left, let's do the left side first. So let's do A. So for line A, I want to, remember, Y equals Kx, right? Sorry, Y equals K times X. If I divide this by X and divide this by X, these two x's cross and I get K equals Yx. So that's how I got K equals Yx. I'm just rewriting this in terms of K. So let me erase that. And then I'm going to write K equals Y over X. So let's pick a point on this line that is exactly the same. And let's pick this one right here. So this point is 2 and 7. So 2 and 7. If I substitute, I get K equals 7 over 2 and K equals 3.5. So this is not the line that has a constant proportionality of 1. Let's look at line B. Again, let me write K equals Yx. Let's pick a point on this line, and there's so many. So let's pick this one, 2 and 2. So on 2 and 2, X is 2, Y and 2, so this one is easier. And you get 2 over 2 and K equals 1. So already we know that line B has a constant proportionality of 1. C, just make sure, I don't know. C we can pick, is there a point we can pick? Yikes, no, well C. Yeah, we can pick this line here, 2, 4, 6, 9, 10, 10 and 3. So K, so I pick 10x and 3y. So K equals Y over X, K equals 10 over 3, and that's definitely 1. So the line 1 plus line B. What is the constant proportionality between Y and X in this graph? So, I mean, they pick a little dot there, but you could pick that point. Is there any other point we could pick? Yeah, we could pick this point over here. Okay, so either this one or this one, or any other that intersects nicely. This one looks like it does. Right here. So pick anyone, and just so just to be different, I'm going to pick this point right here, which is 6, 4, 6 on the x, 4 on the y. So constant proportionality, k equals y over x, k equals 6 over 4, and k equals 3 over 2, or 1.5, or 1.5. Any of these three answers will suffice. Okay. Car technician took a car on 4 test rides. For each ride, the technician recorded the miles driven and the amount of gas used. Okay, 4 gallons, 100 miles, 2 gallons, 50 miles, 1 gallon, 25. Do the data in the table represent a proportional relationship? Compare the relationship between pairs. So this is a strategy that they're asking you to do it, so I want you to do that. So you have to, first of all, call this the x and this y, right? So because the miles depends on the number of gallons in the car, right? That's the relationship. So this is the input, this is the output, this is the independent, and this is the independent. So let's take the first one, and I'm going to do it this way. K equals y over x, and if we do that, it's going to be y, which is 100, over x, which is 4, and we're going to get that k is 25. I'll choose a different color. So for the second one, let's see, k equals y over x again, and our y is 50, and our x is 2, and k equals 25. Ooh. Another color, black. We're going to do the third one. K equals y over x, the y is 25, the x equals 1, and k equals 25. And finally, the last one, and do I have another color? Green? Nope, green. It's going to be k equals y over x again, and the y is 12, and the x is 0.5, and that's going to be 25. So it tells me that the relationship here is that it's proportional. So for every gallon of gas, it goes 25 miles. It's proportional. Okay. Yeah, that's it. But I used compare the relationship between data. So I used this point, this point, this point, this point, and compared their constant of proportionality in each pair, and found out that they're all the same. Therefore, they are proportional. Okay. And then what does it say? The points of the graph represent proportional relationships. So we have 3 and 7.3 and 7.8. Okay, so let me write. I'm going to find the values of ratio y over x. So again, same thing. So I'm going to put the values here on the table. So I've got y and x, just to make life easier. I don't know what they're talking about, but so I got 1, 2, 3. So 3, 7.8. Then we have 6 and 15.6. And lastly, we have 7 and 18.2. So does this form, is this line here, if I were to, obviously you can tell that if I were to connect those dots, it looks like a straight line, but let's see. Let's confirm if it's proportional. No, it does start at 0, 0. It goes through the origin, but let's see. So let's do this. I get k equals y over x. K equals 7.8 over 3, and 7.8 divided by 3. It's going to give 2.6. So the constant of proportionality is 2.6 for that one. So let's just see if that repeats over and over with the other points. K equals y over x is going to be 15.6 divided by 6. 15.6 divided by 6 is going to be 2.6, and it looks like it is. And then the last one, k equals y over x again, and the y is 18.2, and I'm going to divide that by 7. 18.2 divided by 7 equals 2.6, and obviously, what do you call? So the unit rate is 2.6 over 1, right? So it's we can also write that the unit rate is 2.6 over 1. So this is definitely a 5, 2.6 over 1, 2, 4, 6, 8. So the unit rate, what its constant proportionality is the same for each one, which tells me that the unit rate is 2.6 over 1. So, and that makes sense because if I multiply 3 times 2.6, I get this. If I multiply this by 6 by 2.6, I get 15.6. And the last one, 7 times 2.6 equals 18.2. So this one is definitely proportional. Okay, it wasn't that difficult, but you just really need to see all the different ways that you can see if it aligns proportional. Okay, and that's it.